Hello, everyone. We are going to be talking today about an oligopoly. All right. So if we go back to our spectrum, we know that on the far side over here, we have perfect competition, exact same products, lots of sellers, and no control over the price, very easy to enter. On our far right, we have our monopoly, one seller, high barriers to entry, and complete control over the price. And so as we did yesterday, we are looking somewhere in the middle. Yesterday, we covered our monopolistic competition. Again, closer to our perfect competition in the aspect of our number of sellers was still quite high, and we still didn't really have barriers to entry, and our products were very similar to each other, with not a ton of control over price, but getting a little bit more. Whereas today we are moving further over here to our oligopoly. Okay. In our oligopoly, we are much closer to monopoly, so we have far fewer sellers. Okay. In all of our modeling and our mathematics and our graphing, we assume that an oligopoly only has 2 sellers. It can have probably up to about 6, but for the modeling that we do, it's really based off of the understanding it's us and one other big influencer or big seller. Okay. For an oligopoly, the products themselves don't really matter. They could be 2 exact same products. They could be quite different either through branding or through features. But again, it is the same market. So we're not talking like apples and shoes here. It's all the same market. I'm just saying it could be phones with lots of different features and lots of different brandings, or it could be if we have only 2 sellers of apples and the products are the exact same. As we are closer to the monopoly side, we do have lots more control over our price. And just like a monopoly, we have very high barriers to entry. Okay, so that is where we are kind of at theoretically. Really, what I want you to think about for an oligopoly is basically 2 main sellers. So in Canada, our best example of this is going to be Rogers and Bell. Okay, as we talked about in class, while there might be other brands out there, you might be like, what about TELUS or Koodo or Fido? Okay, the way the structure is set up, Bell and Rogers own the 2 sets of towers that provide cellular service in Canada. Okay, and so really they are the 2 main players. Even though there's some other names there, they are owned by both of the companies. So again, an oligopoly, there can be 3, 4, 5, but there's really 2 main companies. An example we talked about yesterday was Coke and Pepsi. That would also be an oligopoly, because even though there is No Name and PC Cola, really there's 2 main in the industry that have the control, and so that's the oligopoly that we would be looking at. Okay, so again, these are some of the characteristics we just talked about. Few firms, as I said, 2 of them have a large share of the total output of the industry. Okay, another really important piece of an oligopoly is that there is interdependence. Okay, so it's not one business has the main share and then there's a few other ones. There's 2 big ones where if one of those big firms, if Coke made an action, Pepsi would have a noticeable effect to it, and vice versa. If Bell changed their price, Rogers would feel that impact. There has to be an interdependence in that industry. Okay, so it's not so much that we're talking about how similar are the products in the same market. We're talking about that interdependence, that reliance on each other, and that effect on each other. Okay. As I said, there are large barriers to entries, and the key with an oligopoly is generally that has to do with that large capital investment. Okay, we're generally not seeing government intervention like we saw in the monopoly to create those barriers to entry. We are seeing that large capital investment. And again, as I said in class the other day, paying a couple $1 million for a building and machinery seems large to us. We're talking about substantially large. Okay, we're talking about setting up cellular service across the country if you wanted to get in and truly compete against Bell or Rogers. Okay, and running, like we talked about with the electrical companies coming in and literally running electrical wires across the country and into every single home. Extremely large capital investments. Okay, and this is really important. This is what generally keeps us at only those 2 or those 2 main in the industry. Okay. And as I mentioned, the actual product itself doesn't matter. It could be any aspect of that, as long as we're very clear on the fact that it is within one market. Okay. What I just want to say really, really quickly about our oligopoly, in our simulation that we did in class, we did see with the oligopoly, when we only had 2 or 3 businesses there, we did see them trying to, at least at the beginning, working together. Okay. And I know a few students at the time had mentioned this word of a cartel. Okay. A cartel is the terminology we use when we have an oligopoly, when we have 2 or 3 main companies and they are working together. If they truly work together to keep the price the exact same, then really we are looking at a monopoly, and all of our modeling looks exactly like a monopoly, because even though technically there's multiple firms, if they are truly acting as one and nobody is breaking it, then that is a monopoly. Okay, so when we look at an oligopoly, we are looking at, even though there's 2, maybe 3 main players in the industry, that attempt to work together has broken down. So if we think back to our scenario after the first go round, when one of those businesses lost out on their agreement plan, they broke the deal that they had, right? And one person changed the price a little bit. And that's what eventually happens in an oligopoly. So in all of our modeling going forward, theoretical and mathematical with the graphs, okay, we are at that assumption in the oligopoly that they have stopped trying to work together, or they are not able to work together for reasons we're going to talk about tomorrow. Okay, and they are operating as separate businesses that make separate decisions from each other. Okay. So, as I mentioned, in an oligopoly, there is some control over the price, okay, because of the large market shares that they have. Okay, we are going to see downward sloping demand and marginal revenue curves, as we do always in anything other than perfect competition. And as I mentioned, in all of our firms, always, 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 our profit maximization occurs at the quantity where MR equals MC. So we'll keep that in mind. Okay, for an oligopoly, this is what our demand curve looks like. And we call it a kinked demand curve because, as you can see, right, we have this slope here, and then all of a sudden it changes slopes on us, or it looks like there's this point where there is a kink. Okay, we're going to start by explaining kind of logically why that's there, but you will notice anytime you're working with numbers, that's just what the numbers are going to show you. And so again, if you happen to be looking at a graph or looking at numbers and graphing them yourself and see a kink demand curve, right away you know that this is an oligopoly, and that's a way that you can identify that for yourself. Okay, so the reason why. Okay, there is going to be a price and a quantity that is shown to us from the market overall. Okay, that is going to be ideal for both of the firms. So if we are going ahead, let's say we're talking about Bell & Rogers. Okay, so there is a price and a quantity in the market that is the market equilibrium, and that is going to be here. Okay, so the part where the kink hits, that is going to be the current price and the current quantity that the market has dictated for these businesses. Okay, you will notice that the slope or the elasticity is different above that price and below that price. Okay, and this is why. Okay, we have some assumptions to make. First, okay, let's think about this logically. If Bell is selling at, let's pick a random dollar amount, $20 for X service, okay, and Rogers decides to increase their price, okay, are we as Bell going to increase our price? The answer is going to be no. Right? If they have decided, if our competition has decided to increase their price, we are already at a better situation than they are. So there is no reason for the price to be increased. So this is one of the assumptions we have. A price increase by one firm will not be matched by a similar increase of the other firm. Okay, and so that is why we are seeing this really, really low slope on this portion here. Okay, so if the market has given us this price, if all of a sudden we see the other firm choosing to increase their price, okay, or we increase our price, you're going to notice a very small increase in price is going to have a drastic change on quantity because our competitor didn't increase their price. And so everybody's going to run from us to them. Okay. And so that's why this part of the slope, okay, looks like this, because a small change in price is going to cause a big change in quantity because our competitors are not changing their price. Okay, the opposite is also true. If there is a price decrease by one of the firms, this would be matched by our competitor. Because again, if we are Bell and we see that Rogers has decreased their price, then we know that the customers are going to go to them, and therefore we are going to match that decrease. Okay, and so again, we can see that a decrease in price is going to cause a very small increase in quantity because we know our competitors are also going to be decreasing their price. Okay, so it's not really an efficient way for us to try to get competition, to get customers from our competition, because we know that they're going to be matching that for us. Okay, and so this is the main reason why we have this kinked curve. Okay, and again, that's going to result in a very elastic demand curve at the top. Okay, we know that a small increase in price is going to cause a huge change in the amount of customers that we have. Whereas the reverse is true by reducing our price. Okay, it's going to be inelastic down here because our competitors are going to be changing it the same as us. Okay, and the slides before this just, again, explain exactly what I've talked about here in a few different ways. Okay, so again, we increase price, they're going to ignore us, so the result's going to be elastic. If we decrease price, they're going to match us, and so the result is going to be inelastic. Okay, so however you're going to remember that, or why you're going to remember that, it's up to you. But the important thing to note is that you should see this very inelastic demand curve at the top, our point here, and then we're going to see a very elastic curve at the bottom. Okay. When it comes to the rest of our curves, okay, our marginal costs and our average costs are going to be the same. We're still going to have profit if our price is greater than our average cost. We're still going to have loss if it's less than, and break even if it's on point. We're still looking for our marginal revenue and our marginal cost. The only thing to note is that because our demand curve looks different, our marginal revenue curve is also going to look very different. Okay, and this is what it's going to look like here. Okay, this one is going to be a little bit more complex, and graphing it is slightly more complex, which is why I'm going to take you through a demonstration of it myself. Okay, but what you're going to notice is I want you to kind of look at it in two parts. So if we just focus on this first part up here, you're going to notice that this first part of our demand line and this first part of our marginal revenue line look exactly how we've been seeing them in both the monopoly and the monopolistic competition. Okay, when we see a demand curve that's sloped, we see our marginal revenue line also sloped, also slightly less, okay, and also at a slightly bigger slope. Okay, if we look at this part of our demand curve, okay, and only this part of our marginal revenue curve, you're also going to notice the same thing. Really, if we were to extend these up, it's going to be very similar. Your demand curve is higher, your marginal revenue curve is a little bit lower and a little bit more sloped. Okay, the disjoint here is where this kink happens. What this results in is it results in this jump in your graph. Okay, and so you are welcome to connect that with a dotted line, or you're welcome to connect that with a solid line. We are going to treat it as if that is the marginal revenue line. There's just a little bit of a special treatment of how we actually go about graphing that. Okay, but your marginal revenue line is going to look like this, and you're going to note that where this kink is quantity-wise is where this vertical line is going to run. Okay, so that's your demand, that's your marginal revenue. We then add to it our average costs exactly how we always have. We add to it our marginal costs exactly as we always have. Okay, and then we're going to go about trying to find our profit maximization or loss minimization point, which we know is always where marginal cost and marginal revenue meet. And this is what I meant about dotting line or straight lining it, okay? Most of the time, that meeting point is going to be on that vertical line, okay? And so that's what we treat it as, okay? This is going to give us our quantity. So from this meeting point, we're going to drop our vertical line, okay? That's going to be our quantity for a profit maximization. And then just like we did for monopoly and monopolistic competition, we're going to follow this line all the way up to the demand line. And then that is going to give us our price for our profit maximization. Okay. And then at this point, if we want to be able to figure out our profit, again, we are seeing our price. We're following our up and down line here to the point where it meets average cost. Okay. And that's going to come across there. Because price is higher than this point from average cost, we know we're making a profit, and we could calculate that amount by shading this in here. And that would be our profit area. Okay. So our demand and our marginal revenue look a little funky, look a little different, but once we have those plotted, everything else still runs the same way in the short run. Okay, our average costs get added, marginal costs get added. We do the same thing to find our quantity, our price, and our profit. Okay, and so we're going to leave it in the short run for today, and we're going to go ahead and do our practice activity together. So if you are in the classroom, hopefully whatever teacher is with you is going to be handing out the piece of paper for you to be able to follow along if you would like to. If you're watching this at home, you can just watch and follow along as this is being done. All right, so for our oligopoly practice question 1, we've been given a chart here that looks really, really familiar. Okay, we have our price, our quantity. First, we have to calculate our total revenue. Again, as always, this is going to be our price times our quantity. So we're just going to do that math. From there, we're going to look at doing our marginal revenue. And again, our marginal revenue is looking at the change in total revenue divided by the change in quantity. Okay. When you are doing oligopoly, I really, really strongly suggest that you first look at what this change in quantity is. And I like to actually write it right on here. So 0 to 10 is 10, 10 to 20 is 10, 20 to 25 is 5, and 25 to 30 is 5. Okay, you are going to notice that almost always there is a change in what that quantity looks like there, and that's going to correlate with that kink in our graph. Okay, so again, we're just going to do the math. So 0 to 350, that's a change of 350, divided by this change of 10 is going to give us 35. Here, our change from 350 to 600 divided by 10 is going to give us 25. Okay, here we have a negative change, right? So we're not going up anymore, this is going down. So we have a minus 100 divided by 5 gives us a minus 20. And from 500 to 300 is a minus 200 divided by 5 is going to give us a minus 40. Okay, so yes, you can get minus numbers. We've seen that before. And we're seeing it again now. All right, then we're going to go on to our total costs. Okay, so these are our total costs, and these line up with our quantities over here. Again, our average total costs, we're taking our total cost divided by quantity. Okay, so our first one we can't do. Our second one, so 300 divided by 10. Okay, and we're just going to do the math. 400 divided by 20. 475 divided by 25. And 600 divided by 30. And then finally, we're going to be doing our marginal costs. And again, these are the change. That's why they're falling in the middle. So we're looking at the change in total costs. We're going from 0 to 30. And then we are dividing that. No, I apologize. We don't use, these are in a different order, right? So double check. We're using our total costs. So our change from 0 to 300 is 300, and we're dividing that by the change in Q, which is 10, which gives us the marginal cost of 30. Our change from 300 to 400 is 100 divided by 10 gives us a marginal cost of 10. Our change from 400 to 475 is 75 divided by this change here, which is 5, not 10 anymore. So 75 divided by 5 is 15. And 475, the change to 600 divided by 5 is going to be 25. Okay, so hopefully filling that out is still good. Again, the formulas are the exact same as we have always done. Okay, we are now looking to graph this. Okay, so if you flip it over, you are going to notice that your graph looks a little bit different. That's because our price now needs to go negative for those marginal revenues that are negative. Okay. I'm doing the same thing. Again, as I've suggested, I'm going to use one color for our demand and our marginal revenue line, a different color for our cost lines, and then that leaves us some room later if we need to do anything else on it. Okay, so we're going to go ahead, if you have your numbers, or take a picture of the front side and have your numbers, and we're going to go ahead and do our graphing. So the first thing we're going to look at doing is our demand line. This is going to be our price. Okay, so here's 35 on our price line is 35, and then our quantity on our quantity line, which is 10. So 35, 10 is going to be my point there, and then I'll just keep going down. And you will notice by looking at my points that it is not a straight line. We are expecting that, okay, because we know that this is going to be a kinked line. So when we look at it, okay, you want to find any of the dots that are going to connect to make a straight line. In this case, I have these 3 here that are going to connect to make a straight line, so I'm going to connect those. Okay, it's always going to be a straight line. So for your demand curve, always use your ruler. And then from there, these two can make a straight line. So that's where my kink is going to be. Okay, so connect it all. It is one line. We're going to label it D or D0. Okay, and it is our demand line. All right. Next, we are going to be graphing our marginal revenue. And a reminder, when you do your marginal revenue, this number is going to be on your price line, and then your quantity is going to be the halfway point between your quantities that are here. So for this first one, between 0 and 10, our halfway mark is 5. So I am looking for 35, and I'm going over to 5, and that's going to be my first point here. Okay. Next, I have 25, and my halfway point between 10 and 20 is 15. So I'm looking for 25 and 15. Okay. Next, we are going to have minus 20, and my halfway point here, again, we're looking at 20 to 25. So we're actually going halfway between that. So that's going to be 22.5. So if I go to my quantity here, we're looking halfway between 20 and 25, so it's going to be this line here, and we are going down to minus 20. And then again here, we're going halfway between 25 and 30, 25 and 30, and then we are going down to minus 40. So there's a few ways to go about doing this next part, okay? So you can kind of see that there's the first part of your marginal revenue line, and then there's the second part of your marginal revenue line. But because our marginal revenue is marked on these midpoints, you can see that this isn't a straight line down. These two do not connect. They would be on an angle if I took my ruler and I connected them. So we are not going to do that. We know that it needs to be a straight up and down portion of our marginal revenue line. And that portion always, always, always runs straight down from the kink in our demand line. Okay, so we know right now that a good chunk of our straight line
is going to be, or our whole straight line, I apologize, is going to be at this quantity of 20 because it always goes down from the kink. So what I like to do is I'm going to take the first part of this, I'm going to connect my 2 dots with my ruler so I know my angle. Okay, I am going to connect those 2 dots, but I'm going to keep going until I get to that up and down line that aligns with the kink there, that 20 mark. Okay, the same down here, I'm going to put my ruler on the 2 marks that I'm marking, and I'm going to leave it on that angle, okay, all the way until I get to, and I kind of like to look it out and almost start there, that 20 line, and then I'm going to connect those, okay. The other way that you can think about it if you're looking at it here, when you're looking at your quantities, you want to look for the number before the changes change, right? So this was a 10 change, 10 change, and then it went 20 change, 20 change. So that 20 is going to be where that up and down line works, which is where this has worked out to be as well. So whichever way works for you, okay? And then finally, you are going to draw your up and down line that connects the 2 halves of your marginal revenue curve, and then you are going to write your MR or your MR0, okay, to indicate your marginal revenue. All right, so we have our demand, we have our marginal revenue. Yes, they look a little bit weird, but from here, everything runs exactly as we have always done it before. Okay, so next we are going to look at doing our costs. Okay, so I can do whichever line I want. I have to do both of them. Okay, if this one's a little bit easier for me, I'm looking at my total cost or average total cost, which is 30. That's going to be on my quantity line, and I'm going to come all the way over here. I apologize, the 30 is going to be on your price line, and I'm going to come all the way over here until I get to my quantity, which is going to be 10. Okay, so I'm going to look for my 30 on my price line, and my quantity is going to be 10. Okay, my next point, I have 20 and quantity of 20. 20, 20. Okay, next I have 19 at 25, so 25, 19. Okay. And then at 30, I'm going to 20 again. Okay, and then I can go ahead and connect those dots. Again, here, this is my bottom from 20 to 19 to 20, and then up to this one up here. Okay, and that's going to be my average cost or my average total costs. Okay, then I have my marginal revenue. Okay, again, just like, marginal cost, just like marginal revenue, it's always going to be graphed on the midpoint of the Q. Okay, so our first one is a 30 on the price line, and my midpoint of my Q is a 5. Okay, so I'm going to go 30. My midpoint on my Q is my 5. So it's going to go there. Then I have a 10 at 15. 15. 10. Then I have between 20 and 25, just going to be this line here, I have 15. So we see it coming back up. Remember that check mark line that we have. Okay, and then between 25 and 30, we're going up to 25. Okay. So then I can just kind of connect the dots. This is going to be my lowest point. Okay, and that gives me my marginal cost. All right. So now that I have all of my lines, I can look back to my question, and it says determine the price and output that the firm will produce. Okay, this always is going to be where marginal revenue equals marginal costs. Okay, and so personally, I'm going to take another color because I got a lot going on here, and I need to find the point where marginal revenue, which is this funky line here, meets my marginal cost, which is this one here. Okay, and so that is right here. Okay, And so I can draw my dotted horizontal or vertical line that goes all the way along here. Okay, that gives me my quantity of my output to be 20, so I can go ahead for Q and put that in here. Okay, and for price, again, even though this is the meeting point that has determined it, just like with monopoly and monopolistic competition, we are going to go all the way up to our demand line. Okay, and we are going to then go straight across. Okay, and that is going to give us the price that they are going to charge, which is going to be $30. Okay. The last thing that we are being asked to do is to determine the profit or loss. Okay, so we already have this line here. We're then going to follow this dotted line down to where it meets the average cost. We're going to make our horizontal line across here. Okay, we know that this whole area here is our profit. Okay, and if we want to do the calculation of that, okay, we are going to take our price, which is 30. We're going to subtract where the AC is, which is 20. And then we are going to multiply that by our quantity, which is 20, basically finding the area of the box. So 30 minus 20 is 10 times 20 gives us $200. So our profit is $200 in the short run. All right. So this is how you are going to be going ahead and graphing the oligopoly. And with this, you're going to go ahead and try it on your own with the other practice question 2. I forgot to write the 2 on it. You could put the 2 there. So you'll notice it looks very, very similar. So go ahead and do the exact same thing. Graph it, find your information, your quantity, your price, and your profit. Okay, there is a question about the long run. We haven't learned that yet, so don't do that one. All right, good luck.